area specialists have found that utilizing our new $10 billion toy, the departure plan would take a completely long time before it becomes a reality. On the off chance that it goes according to plan, the journey to Proxima would require around 2 decades. Taking all matters into consideration, it will probably be many years before we can verify if there is indeed life on that planet. The deep-rooted question remains, are we truly alone in this universe? The James Webb Space Telescope has detected some non-human-like things far from Earth, driving us closer to a possible response from the Navy. Our quest for life beyond our planet has been extensive throughout every stage of human development, to the extent that we have suspended many media writings and speculations concerning this matter. Our wonder regarding our place and solitude in the universe has been constant, as if it's ingrained within us to continuously search for a companion, no matter how alien. Surely, we are getting closer to the answers we care about, but they might not be the answers we are seeking. They could be significantly more terrifying. Join us as we investigate the latest revelations in the realms of universes and planets on the journey to discover something we might not be prepared to see. Researchers have determined what might be the most earth-shattering discovery ever. Back in 2021, when the James Webb Space Telescope was planned to launch, a very captivating speculative inquiry was raised about the capabilities of our technology. The inquiry was whether our telescopes could eventually detect artificial light on another planet, such as Proxima b. Proxima b, the nearest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the small star Proxima Centauri, about 4.5 light-years away, since the exoplanet is much closer to its star than Earth is to the Sun. Proxima b is expected to be tidally locked, with a permanent day side and night side like our Moon. Speculative advanced human development on Proxima b could transfer heat and power from the day side to the night side using photovoltaic cells that produce energy from starlight. In a paper with Manas Lingam as one of the scientists, it was shown that extensive coverage of the day side with solar panels could be detected with future telescopes. Given that JWST has been further developed, it might allow us to extend our search for artificial lights to habitable exoplanets like Proxima b. Currently, in 2024, it is possible that the James Webb Space Telescope did exactly that, using its enhanced sensitivity and broader range of capabilities. JWST could have found the lights we were searching for and potentially propelled us into another significant phase of human advancement. Let us delve into the universe of planets and exoplanets to understand how this was even possible. James Webb's primary mission is to study Proxima Centauri's secrets over time. Humans have long contemplated the nature of the universe. What are we? Where do we come from? Where are we going? These are natural but very difficult questions that humanity has tried to answer since we gained consciousness. Currently, in a time of dramatic technological progression, one wonders whether we are any closer to answering any of these questions. If you ask a philosopher, they would most likely say we are presently at stage 0 of understanding ourselves within the universe. But ask a space expert the same question and watch them bounce around in exhilaration as they hurry to inform you of the latest revelations people have made about the universe using their advanced tools. These gadgets, albeit not given much attention by the general public, are direct indicators of human progress. We currently have the world comfortably accessible, and it is time we push ahead and make the universe easily observable too. One such way of achieving this has been concluded by researchers and astronomers. It is through the innovation we harness. A particular creation of that said innovation is currently responsible for the new revelation of what might be lights on another planet, light years away. Indeed, we are discussing the James Webb Space Telescope. The James Webb Space Telescope is an invention conceived out of the traditions of human campaigns into space to address some age-old questions. Are we alone? What else is out there? Where do we begin, and where do we end? Indeed, this infrared astronomy device has proactively started responding to these inquiries, albeit to some degree. First, you may ask, what even is Proxima b? Proxima Centauri b, or simply Proxima b, is sometimes referred to as Alpha Centauri b. It is a super-Earth and it orbits an M-type star. Super-Earths are a category of planets that are more massive than Earth, but lighter than ice giants like Neptune and Uranus. They are quite unique. They can be made of gas, rock, or even a combination of both, and their sizes can range from twice the size of Earth to a few times its mass. They truly put the super in super-Earth. Regarding Proxima b, it is a super-Earth and an exoplanet, meaning it is a planet outside our solar system. The first feasible evidence of an exoplanet was discovered in 1917, although it garnered little interest and recognition. However, in 1992, the first confirmed identification took place, which left researchers astonished. Another exoplanet, one that was first identified in 1988, was confirmed in 2023. As of April 1, 2024, there are 653 confirmed exoplanets in 161 planetary systems, and of these, 896 systems have more than one planet. These grand revelations orbit an M-type star. To understand an M-type star, you need to understand a red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star. They have extremely low luminosity, and because luminosity is one of our primary tools for planet discovery and observations, red dwarfs are not that easy to notice. These elusive stars have variable definitions and names depending on their temperatures and sizes. For instance, M-dwarf or M-type main sequence stars have a surface temperature of about 3900 K, hence the name. Returning to Proxima b, its mass is thought to be equal to 107 Earths. Rather, it only takes 11 days to complete one orbit of its star, compared with our 365 days. You can gauge the size of the star Proxima b is orbiting, particularly under the estimation of the entire electromagnetic spectrum. The star has a total radiance of just around 16% that of the Sun. Additionally, in terms of light spectrum, its radiance appears much dimmer as it illuminates only 0.56% of the Sun's radiance in the visible light spectrum, emitting a notably lesser amount of light energy compared to the Sun. More than 85% of its emitted energy is in the form of infrared radiation. Orbiting around 0.4856 from its star, Proxima b's discovery was announced way back in 2016. You might be asking, why Proxima b among a myriad of stars, planets, and systems? Why are we so focused on this specific celestial body? Certainly, there are some reasons contributing to the fascination cosmologists have with Proxima b. Most importantly, it is the closest known star to our Sun, and by definition, although 425 light-years is a large distance to us Earthlings, in the grand scheme of the universe, it is a mere blip. Therefore, Proxima b, our nearest known star, is high on the priority list. It is also part of the triple star system called Alpha Centauri. Despite Proxima b's low luminosity, the actual system appears as one of the most remarkable star groupings in the night sky, just behind two others known as Sirius and Canopus. But the most intriguing aspect of Proxima Centauri b is that it might potentially be habitable as it falls in the habitable zone. The potential surrounding the star is immense, and for this reason, cosmologists have taken on the task to explore the depths and bounds of the star's capabilities. This is where the James Webb Space Telescope comes in. As JWST continues its exploration of the said exoplanet, we get closer and closer to achieving these missions, from say to exoplanet exploration in the quest for additional terrestrial life. So, what exactly is say? Since humans have always been an inquisitive species, clinging and pushing into everything that moves and doesn't move, it is no surprise that a task like say emerged on such a grand scale. Imagine that God has coordinated a perfect grand expedition, but with a twist. Instead of gold, we are tasked with searching for signals, specifically electromagnetic whispers from civilizations beyond anything we could ever imagine. SAY stands for Search for Extraterrestrial Intelligence, and it is our collective effort to understand signs of intelligent life lurking amidst the stars. Our quest continues forever. Way back in the mid-1900s, not long after radio technology came into human use, geniuses like Nikola Tesla and Guglielmo Marconi came up with a unique idea. They hoped to use these novel instruments to make a real connection with the stars directly. Tesla even ventured to imagine the concept of communicating with Martians using his wireless transmission system. Fast forward to the 1960s, and we find ourselves amidst Project Ozma, the brainchild of the audacious astronomer Frank Drake. Equipped with a powerful radio telescope, Drake scanned the cosmic airwaves for signs of something happening beneath the surface, but unfortunately, his efforts yielded nothing. However, the quest continued, with researchers worldwide tuning their antennas to the cosmic symphony. Meanwhile, over in the Soviet Union, our companions across the Iron Curtain were also keen on the cosmic chatter. Driven by the renowned ISF Ovsky, Soviet researchers turned their antennas skyward, searching for those elusive transmissions from the stars. Thus, the stage was set for a cosmic confrontation. But wait, what's this? An extraordinary signal was received amidst the immense noise, bringing the chatter and nerves to an all-time high. Named the WOW signal, it sent shockwaves through the scientific community. As the years went by, the search for cosmic partners only escalated. From SETI to the ambitious Project Cyclops, researchers went all out in their quest to resolve the cosmic mystery. Then, in a lucky turn of events or perhaps fate, a coded radio transmission from Mars graced our telescopes, igniting the flames of interest once again. But what does that investigation look like now, and how far have humans progressed regarding space missions? Lighting on Proxima b, in a 2021 research paper titled Detectability of Artificial Lights from Proxima b, experts Alistair Tabor and Abraham Loeb embarked on a mission to investigate the potential for detecting artificial lights emanating from the dark side of Proxima b. Considering Proxima b is located in the habitable zone of its star, the study aimed to examine whether Proxima b could potentially support intelligent life and how to detect it. After presenting Proxima b's importance as a target in the search for extraterrestrial life, they developed a juicy yet startling conclusion: the new speculative radio transmission detection from Proxima b's direction. It wasn't received just yesterday, but in the realm of space where facts take light years to travel, everything is a step forward. This created a buzz among the technological and astronomy fan community. The tentative radio transmission added another layer of thrilling mystery that space experts can hardly wait to unravel. The transmission was detected by the Breakthrough Listen mission and represents a possible contender for a more terrestrial radio emission originating from the vicinity of Proxima Centauri, the host star of Proxima b. The Breakthrough Listen mission, launched in 2015, aimed to survey the sky for signals indicative of technological civilizations beyond Earth. In pursuit of breaking through the barriers of space and listening for any form of communication, using cutting-edge radio telescopes and data analysis techniques, the project could scan regions of the electromagnetic spectrum, looking for unusual transmissions that could not be easily explained by natural phenomena. This search continued for years, and the speculative radio transmission from Proxima b's direction is incredibly valuable. Cosmologists handling the project detected a narrow-band emission at a frequency of around 982 MHz. This frequency falls within the range commonly associated with artificial radio transmissions, such as those used for communication purposes on Earth. It was an exciting discovery that opened the door to a whole new array of potential outcomes. Although the signal has not been conclusively attributed to an extraterrestrial origin and might have alternative explanations, the discovery remains a significant milestone in humanity's history. With the signal established, it was time to evaluate the evidence.